Hi guys, welcome to the another episode of Let's Talk podcast.
And today's topic is artificial intelligence, that's called AI.
So the goal of today's podcast is to give you guys a basic information about AI and all the terminology that are used in AI and machine learning.
Yeah, myself, Bhavin, and we have Sairaj today, and we are discussing Sairaj has some of the experience of real experience of AI technologies. So we are just explore the AI basic terminologies and everything in this podcast. So basically, at the end of this podcast, you will get some of the idea about the AI and how can we start to learn AI and everything. You can have a basic idea. Even we are including the topic of ML also, machine learning, correct? So the thing is like, Sairaj, what is the definition of like AI exactly? And another thing is definition in a real meaningful, like basic.
Okay, so thank you, Bhavin. So first of all, let me give a brief summary about my experience in AI and machine learning. So I completed my graduation in 2019. I've been working on machine learning domain for past 6-7 years.
Oh, super.
I have published multiple research paper. I got like 20-30 citation in last year almost, and I've been working with various clients all around the world in ML and machine learning, ML and artificial AI domain. So that's brief discussion about my experience with machine learning and artificial intelligence. Okay, so now your question was what is AI? To
Yes.
put it in simpler term, it's just a simulation of human intelligence. So what AI tries to do is try to replicate the behavior of human intelligence. So the way human learns or the way animal learns, that's what AI tries to simulate using machines. So that's basically, you can call this as a basic definition of AI.
Mm, correct. So ultimately, AI is using ML.
No, that's not the case. AI is not using ML.
Okay.
ML is part of AI. Okay,
Okay.
so think about it. It's like a sub. You can call it like AI, machine learning as a subdomain of artificial intelligence. So,
Okay.
okay. So before we go to what is a machine learning, let's get back in the past. Okay,
Okay.
let's go back to 1940s where everything regarding computer started. Okay.
So ultimately, now you are introducing or you are giving the information about the history of AI, where the stands from and comes from the AI concept and everything, right?
Yeah, because in order to understand anything,
Yes.
you need to know where it came
Yes,
from,
exactly.
right?
The history and part.
Yeah.
Correct.
So, so like in 1914, as some of you probably know, Alan Turing proposed a theory of computation, which
Mhm.
states that all the mathematical deduction in real life can be simulated using the basic symbols such as zeros and ones.
Correct.
And that basically formulated the base of all the computer technology that we are using right now.
Mhm.
Okay, so then in 1956, a, a workshop in Dortmund College started research in AI domain. Okay, and these guys basically became the founders and leaders in AI research. And by 1960s, because Cold War is on its peak, so they received a good good they received support from government basically, and they got some funding. But they were trying to achieve general AI, and because general AI at that time there wasn't no computation or anything, so the results were not there, and all of a sudden the all the funding that they were getting from the government stopped. Okay, and this is called as winter of AI, which where basically the funding has become very difficult
Yes.
for all the researchers in the field.
So I have one question here. So you have used general AI terminology. So can you just a brief? Can you give us like what exactly the meaning of general
So
AI?
general AI is basically like a super intelligence. Okay, so super intelligence, the human mind is considered as super intelligence because we can predict behavior, we can predict object, we can classify objects, and all those things one person can do that. So that idea of general AI basically came from that. So basically, a single computer should be able to do all these human tasks that we perform day to day. That's basically super intelligence. Whereas there is another term which is called narrow AI, so where you can do certain tasks. So like a model, you can train a model to detect particular objects, like doors or chairs or whatever. All these all these objects. It's not general AI. It doesn't know everything, but you can train it to detect particular objects, narrow field.
Okay.
Okay, and that's what happened in 1990s. So because artificial intelligence, due to the funding issues and summer of winter of AI, they lost their reputation in the research domains. They were not getting any funding or anything to perform the research. So 1990s they started working on narrow AI. Okay, so and I don't think they were calling it AI as well. So now we can look back and call it an AI. But at that time they were not calling it AI. They were just these were like machine learning models which are used for basic classifier and regression models. Okay, so regression is basically a technique where you can predict the outcome. Okay, based on the input. So these were just basic techniques that they were using at the end at the end of in any kind of like technical models that we are doing.
Okay, so sorry for interruption. So ultimately, you mean to say human need to give the input, certain kind of input as a training, and based on the training, the machine will reply. Correct? So that is a narrow AI.
No.
Okay.
That's not narrow AI. Narrow AI basically means like, okay, so you know general AI, right? I just explained.
Yes.
Do you have any confusion about general AI?
No.
So general AI basically can do anything. Okay, it's like a Jarvis who
Yes.
knows everything, you know? That's a basic example of it. But narrow AI is just does a particular task. So you can train the model to detect eyes, right? So there are some. Have you heard of retinopathy disease? So it's a disease caused due to a excess amount of sugar in the body, and it affects a person's human vision. Okay, so now you can train a model to detect the severity of that disease. Okay, so is it is very severe or just a normal stage or just initial stage or all those things. That's a narrow AI. It's not a general AI. Its task is simple. It's to detect that eyes, as whether you can give the fundus image of the eyes, and it will detect the outcome. That's narrow AI. It will just do particular
task only for vision.
Whereas general AI is about everything. It can do all kinds of things. So that's what we were doing in 2000s, right? In early 2000s, we were just doing a particular task. It was using as a classifier or whatever. Until 2010, that's when GPU started to come. And in 2011,
can you give the like a full form of GPU, because we know, but certain people are like new in GPU kind of thing. So what is a
GPU is like graphic processing units. Okay, so
why we need
what's the difference between CPU and GPU, right? CPU can perform a task in a serialized manner. It will do one task after another whereas GPU can perform all the tasks parallelly, so it doesn't have to be serialized.
Yes.
So because of that, what happened, because in GPU you can do multiple tasks at the same time, it increases the speed of the training, 20% training, because all those processing which was not possible in 1960s and 70s, which became possible now. And because of that because of that in 2012 in 2012 I think, yeah, into let me just correct it again. Okay, in 2010 actually, in IDSI conference, a team of Dan Carson, they proposed a GPU based supervised learning using back propagation, and this model was 60 times more faster than the normal CNN model. And because of that processing speed, right, so you can train a heavier model basically, and because of that accuracy increase. And this model basically just wiped out all the other techniques that we were using, and they were winning all kinds of competitions in 2011 and 2012, and that basically gives the birth of modern AI that we've been using right now. And if you can check like in the research, even in the research domain, the amount of research has been in multitude right now. It's like 50% more increase in last 4-5 years in the AI domain, all the research work and everything. So the field is moving faster than ever before. And many people consider this as one of the biggest invention in the human history. Okay, and because of all the possibilities that arises from the AI.
So ultimately we can say the actual arise of AI, like from the 2011 to 2023, because of the faster of development happen.
Yeah, because of GPU.
Yes,
So,
because of GPU.
because how much we are able to process data.
Correct.
Okay, now we'll go to some fundamentals of, because now we have explained the history of
History of
machine
it,
learning
yeah.
and artificial
And
intelligence.
what is the objective of AI in a human life?
What?
What is the objective of AI? Means, like why we are introducing AI, like as a what we can say, like क्या AI के जो goals है यार.
Okay. What is objective of AI? Okay, before I give what are the objective of AI, what are the advantages of AI over the traditional techniques?
What is the benefit of AI?
Yeah.
Yeah.
Okay, so what happens? Okay, if you are in programming, right? So what you have to do, whatever the task is, current task that you are having, right? So you have to prepare a code for exactly performing that task. Okay, say like you are detecting some object or something. Okay, you'll write your code, you'll be able to detect that object, fine, and that's been possible for like past 20 years. But the minute something changed, say like lighting condition change, your data won't work. Say like angle change, it won't work. Say like the objects, what do you say, physical attributes change a little bit, it won't work. But when you use AI, right, when you use machine learning, what machine learning does, you can create a database of in all these scenarios. Okay, so like image, you can, while creating the database, you will need to have all the images and everything. So once you have all those images, you can train a model. Okay, and then because you have trained the model in all these scenarios, the model will be more robust. You don't have to write 10 different algorithms for 10 different scenarios. Once you train the model, once it has good enough accuracy, it will work in all these conditions.
Okay, correct.
That's the main advantage, and that's why like this narrow AI that we are talking about. I'm not discussing about generally. I'm talking about narrow AI. Okay.
Yes.
That's the advantage of machine learning and machine learning techniques, that it's robust.
Yes.
Okay, and that's the main objective.
So can you explain like a short path of that model training? So how we are like training a model, only just for some basic knowledge about it.
Before that, we have to explain all the basic terms of machine learning and everything.
Okay.
Then we
So at
can
the
go to training and everything. Okay.
Okay. Yes.
So first we need to understand what is machine learning, what are the fundamental concepts in machine learning. Okay, so machine learning is same. It derives the accuracy, or it derives the model structure, or it derives the pattern based on the experience. Okay, so it's just like how normal human learns, right? Once a baby born, will tell him that this is stable, this is stable, this is stable, and eventually it will learn this is stable. You don't have to tell him. Okay, the same thing with machine learning.
In a different angle also, he can say, and he can detect it is a
like
table.
once you know, it doesn't matter what kind of
he's
angle and
sleeping or
everything,
he's
right?
standing. Yeah, correct.
Yeah, so that's how machine learning works. Okay, and in machine learning, there are multiple concepts that you need to understand. First is machine learning. There are three types of machine learning. Okay, one is reinforcement learning, supervised learning, and unsupervised learning. Okay, so reinforcement learning is something that you've seen in the movies and whatever. This is where you have a reinforcement learning agent. Okay, so agent will be the model, and the task of the model is to maximize the reward. Okay, so it's like how you train a dog, right? So once your dog performs certain action, you'll give them a treat.
It kind of habit, we can say, like we are like sharing, and at multiple times we are performing the same task, so it will automatically learn.
Yeah, so it's like that. So I basically derived from the simple. So I think you might have heard about that experiment with rats, right?
Yeah,
how rats
habit
solve how rats solve the maze. So what they done, they given every time a rat goes to a accurate path, they give some treat.
Yeah.
Okay.
Habit loop.
Yeah. And then it will create that loop.
Exactly.
So reinforcement learning is based on the same concept.
Yes,
okay.
Definitely.
So this is if I'm gonna give some example of reinforcement learning, it will be a recommendation system. So it's like the more you use, the better will be the result.
Yes.
And what is the goal? Goal is to increase your activity, right? All the clicks and everything. So it will try to improve that. So that's reinforcement learning. Second thing is unsupervised learning. Okay, unsupervised learning is here, like second thing is supervised learning. Then we can go to unsupervised. Supervised learning, where you had to, before training, right? You had to label every single input. Okay, so you are training a model to detect dogs. You have to label it as a dog. Okay, training model to detect cat. You have to label it as a cat and then feed it to your neural network.
Okay, means accurate information with a labeling kind of thing. Like whatever the photo, like image or something on the front of you, and you are labeling it. That this is a dog. So that is
Not
called
accurate. I mean, yes, it has to be accurate because
Yeah.
you are manually doing it. If it's not any accurate, then result will be wrong, right?
Yes.
You have to give proper annotations.
Proper input,
okay, and it has to be accurate.
Yeah, exactly.
Okay, so that's basically supervised learning, where you annotate every single input data. That's in unsupervised learning. What you do is you just feed that data, and then models like model or whatever the algorithm that machine learning algorithm, its task is to find a pattern and create clusters. Okay. So that's unsupervised learning. Okay, so example of supervised learning is basically how you train a normal model to take dog, cat, whatever.
Yeah,
that's
exactly.
unsupervised learning. And whereas that's supervised learning. Whereas unsupervised is just creating clusters. So imagine if you want to detect.
I have so many data,
Yeah.
and I'm just populating some of the machine,
Yeah.
and based on the machine backpropagation, it will be automatically learning and
Yeah, so you say you
automatically
have
classify all things.
Say you have random data of cars, right? Okay, now you have to do analysis of it. You have to find some result.
Okay.
So then you can use clustering techniques. So it will cluster. It will create multiple cluster based on pricing, cluster based on where it's sold, how many sold, and all those things.
Correct.
And you can use that data for analysis. So basically you use unsupervised learning for analysis, whereas supervised learning is used for classification. Okay.
Directly you can give the tag.
Yeah,
and
exactly.
It will be,
So these are basic terms of machine learning. Supervised, unsupervised, regression learning. Okay, now there is another subdomain. So now all these things became possible because of artificial neural network. Okay, so what is artificial neural network, right? So artificial neural network works similar to how human neuron works. Okay, so all these neurons are connected to each other. It will have a regression layer so there are multiple layers. It will have regression layer in the end, and it basically determine the probability of each object. So when you pass it, okay, and it has a back propagation. So you can train the model. So say like you have 1,000 images with 10 different classes. Okay, let's say 10 different animals. So what it does, it divides that 1,000 image first into testing and training sample. Okay, then for the training images, okay, we usually use 80% image for training. For training, what it does, it divides that training data set into number of patches of 64, 32 images. Okay.
Correct.
Okay. Once it divides that, then it tries to learn the pattern between all the classes. Okay. And at the end, what it does, it cross validate everything.
Okay.
So now you have testing data, right? So what it does, so you send a cat image. It tries to if it is cat or not.
Yes.
If
So
it's not,
classified.
yeah. So then you will get an accuracy for it. And whatever the feature it learns, it back propagate to again to the input and learns the same feature again.
So multiple time learning,
Yeah,
multiple time learning, and give the accuracy of data 80%. That is also probability, right? Probability.
What 80%? No, 80% is you divide the data into training. So you have 1,000 images, right?
Correct.
So you can use 800 images for training and 200 for validation. Okay. So that's what I was talking about.
Yeah.
Okay, and the accuracy, you can get accuracy up to 98, 99% easily. Right now the models are very good, so you can get a very high accuracy. Okay.
So I have a question. Like if some, for example, some of the image are very accurate, some of the image are like blurry. So in a model automatically classify it, or it will like in a multiple learning time, or it's having some issues sometime.
Okay, so what we do while training, okay, so there's a concept called image augmentation. So because we want to make the model very robust, right? So robust as in should work in all different conditions. So what we do, first thing is while preparing database, it is important to create images for all the scenarios. Okay, so lighting condition, everything, and even after that we use augmentation. Augmentation is a technique where you can flip the image, change some properties, like you can flip the image, you can increase the brightness, decrease brightness, increase saturation, all those things. Okay, so when the input image of such a condition comes, the model will still work. It will be robust enough.
Okay.
So that's what we do to increase the accuracy of the
Accuracy
model.
of the
It's called a data augmentation.
Okay.
So we'll feed all those images and the model will be trained.
So nowadays the intelligence or model are very intelligent, correct? We can say models are very intelligent. Like have
That depends upon what do you mean by intelligence. What do you
Yeah.
mean by intelligence?
like accuracy, we can say. Like
Like accuracy you can get by normal as well, right?
correct, but we are training up, right? So but you can say like narrow eye AI or something, right? There is some inputs are like blurry or something, so we cannot detect it, correct? But the thing is nowadays the models are having a different back propagation, right? So at the time it will clearly that blurry information also they are using for some of the era, correct?
Okay. Yeah. So intelligence. That's why when we describe everything, I describe it as ML. Okay. I don't
Yes.
talk about AI because that term has been used a lot. So in these scenarios, like what is intelligence in this? Intelligence is it's a robust,
Yeah.
and that also depends upon what's your input. So because normal techniques like non-traditional image processing or whatever, the minute the different scenario comes,
Yes.
the 100% will fail.
Yeah.
Okay.
Correct.
But with AI, that's because we are trained that model in different scenario, right?
Yes. Every angles, everything.
So, yeah. So that's why it has that intelligence.
Yeah.
But it's not like a general intelligence.
Yes.
It's just narrow-minded,
Narrow.
right? It can does that particular.
Only particular things.
Yeah.
It is okay.
Yeah.
It is not
exactly.
generating based on the like something it can imagine or something. It's having some input and give the some output. Correct.
Yeah, exactly.
Yeah. Okay. So like we can go ahead. Correct. So but yeah, you're talking about the neural network, right? So anything else like we have anything like to cover in a neural
Yeah,
network?
so there are so much thing we have to cover in neural network, right? So I'm not like the technical part we are not going to discuss because
Okay.
it will take I don't know how many hours to explain
Yeah.
all.
But
all
just
the basic
overview
terms.
how many types
So
of are there?
overview, if you want to give like it's inspired by how human brain works, right?
Yeah.
How human neurons work, and it's based on the back propagation technique, which I just explained it, right? So that's the difference between traditional models and neural networks because we train that model on multiple images and all those conditions. This model will be robust. That's the idea, right? That's the idea.
Correct.
And you can have a higher accuracy with a more advanced architecture. So that's basically neural network. We'll probably do an episode in future where we can discuss about what are the neural networks, like convolution neural network, which is used for image processing, and there is RCNN. Okay, so RCNN is a recurrent neural network which uses LSTM technique. So LSTM is
long short term
long short term memory. Okay, so because LSTM is RCNN used for text analysis, right? So when you do text and error, because if each word has a meaning and if you want to understand entire meaning of a sentence, you need to understand all the words, right?
Means prefix and suffix and everything.
So you need a memory. So you need a memory because in a normal CNN network, you'll give in one image, it will detect that image. But in order to understand sentence, you need to understand every single word and the meaning. The sentence has the meaning. Word does not have a meaning.
Correct.
Okay. So what LSTM, because it has that long short term memory, right? So because of that, it will be able to form understand the meaning behind the sentence.
Means we can say the sentiment of that word. We can say
because
based on the
sentiment
prefix
analysis is basically understanding
exactly.
the meaning behind
Correct.
behind the sentence, right?
Okay.
So and the example such as ChatGPT and everything is based on transforming, which is next evolutionary step of RCN, you can consider. So that is we'll get into the more complex detail probably in further episode.
Yep.
If we make some episode about this. Yeah.
And can you just give some of the information about the deep learning, because nowadays the deep learning is like very booming in after coming of the ChatGPT.
So first of all, people get confused between difference between machine learning and deep learning. Okay.
They're different.
Yeah.
Oh.
Like deep learning is subset of machine learning.
Okay.
So deep learning is machine learning, but all machine learning is not deep learning.
Okay. So there is a part.
It's like Maharashtra is part of India.
Ah.
India is not part of Maharashtra, right?
Yes, correct.
So it's like a subset.
Mm.
Okay, so what in machine learning you use traditional techniques such as regression and classifier and all those
Correct.
things, right? So that's like a traditional machine learning technique. Yes, like regression and classifier, all those techniques that we have. Whereas in deep learning we use convolution networks. Okay, we use artificial neural networks, right? Basically, deep learning involves neural networks,
Mm.
but okay, so that's the difference. So in deep learning we use neural networks. So because of neural network, it will be deeper model and uses the back propagation.
Mm.
Whereas traditional techniques does not use that
Yes, yes, yes.
back
Correct.
propagation. It just try to correlate the result and that's it.
Okay, so it will like deep learning means multiple time analysis the whatever the inputs.
Deep learning actually uses neural network, whereas neural networks, right, which I just explained,
Mm.
that's basically part of deep learning.
Mm.
Okay, whereas traditional techniques such as SVM or regression,
Okay.
they do not use neural network.
Okay. They are
So,
just
so whatever the neural network we use, they came directly under deep learning.
Okay.
And deep learning was possible because we are using neural network, right?
Yeah.
Sorry, because we were using neural network, we need high processing.
Mm.
Because of all the back propagation and all those things, because neural
Yeah.
is high architecture, right? So
And the name itself, it's like deep learning, so it's
Yeah,
need
yeah, so
deeply
you need
learn,
a
right?
deep
The model
processing,
and all,
yeah.
yeah, correct. So what are the inputs and everything, image or something, right? We need to
Yeah.
deeply analyze the data and we fed that data to accurate our system.
Exactly.
Next episode.
So that's basically what deep learning is.
Mm.
Okay,
Yeah.
so
Have a nice
deep learning is a part of machine learning
Mm.
where we use artificial neural networks such as CNN, RCNN, transformer-based learning.
Mm.
All of these are part of deep learning.
Mm.
Okay.
So here one question. So nowadays, like Chat GPT, right? It's a kind of very hot topic right now. So which technique used behind the Chat GPT?
Okay, so ChatGPT again, it's based on RCNN.
RCNN, okay.
Okay, so I think it uses transform learning, which is based on RCNN.
It's a combine of.
No, it uses transform.
Okay.
So transform learning is like RCNN learning with parallel propagation is possible. That's why it's faster and more accurate, and that's what ChatGPT is using right now.
And it's sensible means kind of if I have some sensible input, so that is also it is detected.
What do you mean by sensible?
Like we can say, right, like it's also based on the text. So prefix and suffix we just now we discuss about, right? It's kind of have some sense or something. It's detect based on the prefix and suffix wording.
Not just prefix and suffix, entire sentence.
Entire
Right?
sentence,
Prefix,
yeah.
suffix, I don't know. But it uses entire sentence
Mhm.
to form understanding or meaning about that sentence. Because you can just go 2-3 years ago, okay, when you're using a assistant on Google and everything. Okay.
Bot.
Yeah,
We
what
can
is the
say
bot and
bots.
how it used to respond. What it used to do back then, it just used to detect keywords.
Yeah,
You
it's
say
keyword.
yeah. So it used to detect keyword, and based on that, it used to predict the meaning. So that's
So it's
why
a predefined, like we can say
yeah, so
whatever the
like,
text and all.
what's the time? It will detect the time,
Mm.
and based on that, it will respond.
Yeah.
That's how you used it. That's why if you see 5-6 years ago, response wasn't that good. But now, it's tried to understand sentiment. It's tried to
Yes.
understand human language,
Yeah,
right?
correct.
That's why it's called human language,
Mm.
natural language processing.
NLP.
Yeah, NLP.
Okay.
That's it.
So it's kind of combination of all over the like ML techniques, right? ChatGPT we can say most of covered.
No, it's part. I just said it's the part of transform learning.
Yeah, transform learning only.
Yeah.
Okay, correct.
Because all these basic concepts will be part of it, obviously, because you can say regression and classification are the building blocks
Yeah,
of machine
absolutely.
learning. It's everything.
So can you give the brief about this classification and regression? Can you just brief like how it's work and where it
So
is placed?
classification by the name suggests, right?
Yeah.
Your
Classify the
it's
information.
just classify.
Huh.
Okay, so you can have an input, you can label that input as whatever,
Okay.
and the classification model will detect that object.
Okay.
Okay, that's
Correct.
classification.
Yes.
Whereas regressions, you can give relation between input and some other quantity, right?
Huh.
And then it will predict.
Hmm.
It's like a stock market, right? You have to predict what's the value of stock in
Okay.
next 2 months, It will analyze the past data and it will predict that. That's basically its regression.
Oh, okay. Means classification and regression. Regression will predict some data, but classification have a labeled data.
Yeah, exactly.
Correct now, and it will be categorized. Okay.